Future value of investments. We'll talk generally about future value, and then we'll do it as in terms of an actual investment on your part. So 2.7, future value of investments. One really important concept, finance, the idea of future value of money and present value of money. You might think, well, what's the difference? Like $1 to $1, it doesn't really matter, right? Like now or a month from now, right? So worth $1. Think of it this way. Let's say somebody owes you $100, and they say, okay, I can't pay you until 6 months from now, right?
For $1?
$100, right? It's going to take me 6 months to pay you. So would you say, okay, if I have to wait that long, would you be more inclined to need more than, a little bit more than the $100 he owes you? Because when would you rather get it?
Now.
Right now, right? You're pretty adamant about that, aren't you? So wouldn't getting it right now be worth maybe some small discount for you? If you do get it now, maybe you settle for $90 versus $100 in 6 months, right? And the uncertainty, right? 6 months goes by, that the person that owes you maybe not even around, right? So you say, okay, well, you can't pay me right now the $100, but if you give me $90 right now, we'll call it, right? So you've discounted that, right? So that's present value. So maybe the present value of $100 is $90, right? But if you got to wait 6 months, maybe you say, okay, if you're going to wait 6 months to pay me, I could be using that money to do things, right? And so I'm missing out on what I could be doing with that $100 that you owe me. So maybe you say, all right, if you wait 6 months, I'm going to need $110 from you. Does that make sense? Huh? No, I'm just saying, I'm trying to be outrageous here, okay, right? I'm going to need a little bit more than 100. That would be your inclination, right? Maybe not you do that, but you get what I mean, the inclination. Like the value of money right now is a little bit higher to you, isn't it? Than it is a year from now or whatever. Does that make sense? Okay? So that's a really important concept in finance. And we're going to approach this present value and future value in terms of like you putting money in the bank, right? But that goes for like if you're running a business, and one way to get inventory on your shelves if you own a grocery store, right, is to, through the supplier, you might not have to pay him immediately, right? But so you have this accounts payable, right? Okay? And if you pay off what you owe your supplier within a month, a fairly short period of time, there's no interest on that, right? That's usually the standard thing. But if you wait more than a month to pay your supplier for bringing you stuff to put on your shelves, it's probably going to cost you a little bit more, isn't it? Right? Because they'd rather have your money right now, and usually they give you like a month grace period to settle it up, right, without any interest or anything. But anything beyond that, if it's an account payable, they're going to charge you some interest, and so it'd be your best interest to pay it sooner rather than later, within the month, right? It'd be in his best interest to get it right now, So as they unload the truck, hand them the money. But you can't always do that in business, right? So you have to work with people will loan you money, defer payment, that kind of thing. And just know that the value of $1 right now is greater than the value of $1 in the future. Okay? And so if it's greater right now, you'll accept less. Does that make sense? Right? Because a little bit less is like almost like the equivalent of getting the whole thing later on, right? That makes some sense. Okay? But, all right, so now I want you to have that in your head, but now we're going to apply this future value, present value to an investment, right? So, like, you take money, let's say you take $100. You could spend that right now, right? Okay. But you're going to take that money and you're going to put it into some account in the bank and leave it sit there. So now you're not using that money. You don't have use of it, right? What's the trade-off? What are you possibly gaining from that? Like, you're going to give the bank that $100, and that $100 you won't have to spend. Okay, so you're looking for some payoff at the end, right? For foregoing the ability to spend that $100 right now. That make sense? And so that's why you put it in. So it will have a future value, and you would expect to have more than the 100 after you let someone else hold on to it for a while, right, and make it grow. Because otherwise, you want to just hold on to it, right? Let's say interest rates are 0, which you're getting really close to right now, and have been for a while, and things are going. If interest rates are 0, would you put that money in the bank and not have it available to you? Like, why? Well, there's no payoff, right? Let's say interest rates are like it was back in the early 80s when they went nuts. Let's say, 15%. It's outrageous, but yeah, it got that high, 20%. You'd be more likely.
You'd be loving that thing.
Yeah. Well, now the flip side is, right, that you're saving, if you're putting money into an account as a savings account or investment, good for you. What if you're taking out a loan at 15, 20%? That's no good for you, right? So it all gets traded up. But forget that side. You would be more likely to put that $100 in the bank at 15% interest than you would at, say, 0% interest and not get to use it. Does that make sense? So, that being said, we have a couple of formulas here. And it's going to get formula heavy, right? And kind of messy and complex, a couple of them. One of them we've already seen. Now, you can put money in the bank as one. You can take that $100, put it in the bank, and never put anything else in there, right? Just let it ride, okay? That's one way to savings growth. Another way is to, every month or so, put $100 in. So that first $100 grew for a month, right? And then you put another 100 on top of that. Like periodically, you just keep putting money into the savings account, right? Like maybe every time you get paid, take $50 your paycheck, put it into an account that earns interest. So not only is it growing because you keep putting more in, it's getting interest added to more and more and more, right? Compounding interest on top of you putting more money in. And so that's a different formula, right? It gets a little muddy. Like how do you figure out what the future value of it? So maybe that single $100 investment, you want to put it in for a year and have $110, when it goes out, right? And if you were maybe more ideally, take $1 million and put it in, and then a year from now you got yourself, 10,000 or 100,000, right? Well, maybe it makes more sense doing it with bigger numbers. But anyway, so let's look at a couple of formulas. The future value of an investment. And we just abbreviate it FV. Okay? The future value is really just our compound interest formula. It's the same formula we've been using. Future value of a single investment. Okay? I'll just define it here. Anyway, it's the value of an investment at maturity. Value of investment at maturity. What do I mean by maturity? Yeah, that's like an agreed upon time that you come and get your money that you put in plus the interest. Like if it's a CD, like it's fixed deposit, a 1-year CD matures after 1 year, okay? A treasury bill, or like grandma would get you, right? Might mature after 10 years, 20 years, right? Right? They all have different maturity terms, okay? So the formula for future value, FV, of a single deposit, the one we talked about a minute ago. Oh, gee whiz. Oh. Itch. Okay? That is just our compound interest formula. FV equals principal times 1 plus R over N to the NT. So maybe you put it into a CD. So this formula is not wildly crazy, right? You've been using it over and over again. to a CD at a rate of 2%. I mean, you know how this goes, right? I mean, the CDs are compounded monthly. Or maybe the CDs compounded continuously, right? Then you have to adjust it, right? But that's for the future value of a single deposit. Now, here's the case for when you're putting money in each month, right? Or every compounding period, okay? What's that? Thank you. Okay. Sometimes like I'm thinking like so far ahead of what I'm writing, it just disappears from it. Yeah. It's like I know how to spell single, but I'm trying to think about how to present this to you as I'm going and write at the same time. So you try it sometime. That's exactly what it is. All right. Anyway, now future value of a periodic deposit. What did I spell wrong? I fixed it.
No, you didn't read it slowly.
Oh, for the love of Pete. N-G-L-E. Well, that's encouraging. At least you guys know how to spell. I don't. All right. I'm going to slow down. Future value of periodic deposits. I'll do it all. Okay. So we have this one, right? Again, that's just your compound interest formula. This one's a little messier. Okay. So that balance will equal the following. And we got to double the parentheses here, right? 1 plus R over N to the NT minus 1. Look at this mess. Like that. Okay? All over R over N. Well, be either way, it doesn't really matter too much, right? The point is, it's going to be your balance at the end. Now, here's a little difference here, right? Now, up here, P meant principal, okay? So this is an important distinction right here. The P here equals the amount of periodic deposit. Okay, not the principal like we had been working with. So let's say you're going to put $50 a month into an investment. Every month you go down to the bank, put $50 in. Okay, that P will be 50. Is it payment? Think of it as payment, right? In this case, make sense? Huh? Payment. The act of paying. No. Don't think of it as painting. That won't help you. Okay. So let's see. So now the second one, as you can imagine, trying to put this all in your calculator could get a little tricky, right? Right? Nesting the parentheses and grouping things. And like, by the way, on top, when you put it in your calculator, you need like another set of parentheses around the top stuff, right? And then another set around the bottom. You actually go to put it in, okay? So you have to keep track of your parentheses nesting. And after you guys demonstrate you can do this a couple times, then I will show you a shortcut, a neat little finance feature on these documents, okay? But first, of course, you have to demonstrate that you can do it, all right? So let's go to example 1. Simone, would you read example 1, please?
Rich and Laura are both 45 years old. They open an account at the Rhinebeck Bank with the hope that it will pay them up interest by their retirement age of 65. They deposit $5,000 each year into an account that gives 1.25% interest on
Hey, can I stop you there? So it says right there they deposit $5,000 each year. Which formula are we going to use? Okay, there we go. Go ahead, keep going.
What is the account balance of which Chris and Laura retired?
Okay. So let's work this out. So they're 45, and when do they want the money? Age 65. All right, so what's the value of T in our formula? All right, 20. Everybody with me? And what's the periodic deposit P? Each year. 5,000. Okay, so that's each year they do that. And what is the rate? 0.125, right? And then we have, okay, the number of compounding periods per year. What's the value of that? 1 is because it's compounded annually. I think they could probably find themselves a better investment, but that's what the example is, right? Okay? Be nice if we could find something compounded monthly, maybe at least, right? Anyway, let's plug this into that mess, because that's the one we're going to use, okay? So our balance is going to equal 5,000. We're going to double up these parentheses here. Times 1 plus 0.0125. That's over 1, so that simplifies a little bit, right? To the 1 times 20 and minus 1 all over 0.0125 divided by 1. So that really does kind of simplify it, right? And I want you guys to put this in your calculator with the 1, right? Because I want to make sure you can do this correctly. And let's see if we can enter it without any errors. Remember, we got to group the top and the bottom of this. So we'll leave some extra parentheses to go in. I'll do this thing here. Add a stretch pad thingy.
Do you know there's a fraction button?
What's that?
Do you know that there's a fraction button?
No, I don't. When I hear that out of anyone's mouth, no. Used to like, no, have some dignity, some pride, please. No. You want to get up in the morning and actually face people, don't use that button. All right, seriously. Have a little self-respect. What's wrong? No, I don't want to get started right now. If we have time, I'll go on my
Enter the top and bottom
rampage
separately.
about it. I won't use it. Use divided. Use divided and group properly. I don't care. We're going to put in.
Is it 400,000?
It is not. Yeah, good job with the fraction button. Times 1 plus 125.
Oh, because I put times 1 instead of minus 1.
Yeah, I used fraction button and I got to
Out here, the exponent.
see the way you're doing it, more complicated.
I know, but I'm not. I'm here to make it smarter. Minus 1. And notice how I got out here grouped up like that, right? I'm going to do divided by. See that? So no man. I don't need a fraction button.
You just make it more hard.
So that's right.
I got 0.
0.125. That's unfortunate, Carly. Divided
I
by
got 0
1.
doing this
Let's
one.
see if I got it right. You should get, make sure you get $112,814.89.
Yeah, it is good. I did use fraction buttons.
I didn't. I got
User.
0 doing this method. And mine was
Yeah.
the
Stop
exact
the
same
fraction
zeros.
button. Stop.
I didn't know I got the same method.
Is this?
Yes.
We'll do it without the fraction button now.
I did that too.
So you did it without it and got the same? Okay, there you can see. Don't you feel better now? Don't you feel a little better than these guys now? Right?
I got 0.
Hey, Simone's better than you. Okay.
I've known this.
Okay. In every way possible, right?
I still have 0.
Right? She's going to end up driving a nicer car, making more money than you guys. 112,000. 814.89. And that's what, so when they put that $5,000 in for each year for 20 years, they'll end up with 112,000 change retirement. Not much.
How did I get zero?
I don't know, Carly.
I put in the same two I checked.
Did you? Zero.
I don't know.
Did you put in parentheses around the outside? So it's like another set of parentheses, not and parentheses down here. Okay.
Looks exactly the same.
Well, let me just go take a. Let's try this again. Let's do the check, okay? Let's do the check. I want you to write out your formula, put it in your calculator, please, without the fraction button, okay? And they're asking like how much more, right? So we got to do kind of the same thing, and then to find out how much more, what do? Subtract them, right? So now, what's changed? What changes in the check? The time, right? That's what is it now? 21. Yeah, there you go. All right. So your balance now. Wish they changed the rate on this. Equals 5,000. 0125. 1 times 21 minus 1. All right. Over 0.0125. 1. Let's start with what did they earn at the end of 21 years, and we'll do how much more. How much did they earn?
I got 119,000.
119, 225.08. There we go.
See, I can't do it without the fraction. It's actually not just these.
Oh, God. 25.08. So then they did ask how much more, right? So what do we do now? Right. So we do the 19225.08 minus the other one, which is 120.15.
99 gets 0.08, I got 5.
Yeah.
Wrong.
Point, what was it, 89? So I think it's 6410.19. More. Just by waiting a year, another $6,400. Right? I think it really should have found something that compounds a little more frequently. Is that? Okay. That's kind of way they didn't really put a lot of thought into that.
That was their choice.
Okay.
Looking
Close.
for-
Now, example 2 ties into this, right? Example 2 ties into, so here's what they made 20 years, right? What is example 2 asking now? Based on example 1.
Well, you read it.
Uh,
How are you the teacher if you don't know how to read?
I haven't read a single question all day.
Carla, read example 2.
I
Just
didn't
go.
say I wanted to.
Okay. Well, now you.
How much interest will Rich and Laura earn over the 20-year period?
Okay. How much interest, right? Well, okay. Let's think about that for a minute. What is interest? Yeah, principal, and you have interest. So interest is what?
What do they have about?
On top of principal, right? So if you knew what the principal was, like how much they put in out of their own pocket, you could, each month, right? You can subtract the 112,000 from how much they actually put in. We have to know, so it's a little more complicated, right? It wasn't a single deposit, was it? We got to figure out how much they put in. And they did 5,000 every year, right?
5,000 contract.
Yeah. Well, what did the problem say in example 1?
Each year.
We need the total of payments, right? So they put in 5,000 times 20 years gives you what? That's easy, right? They put in, so $100,000, right? And everything over 100,000 was interest. So this is pretty simple, right? We just subtract them. Okay, we do the 1112, 814.89, right? 0.89 minus 100,000, and they earned 112,814. Oh, no, they didn't. Hard. They earned 12,000. In interest. That's not horrible, right? It's like they got an extra $12,000 for doing nothing. Nothing but giving up the use of that money, right, every year. And then they just basically sat on the couch until they played Call of Duty until they were 65. Huh? What would I have done differently? Rate's kind of low for that length of an investment. I would have found something with a higher rate. I would have found something with more compounding periods. And I would have put, money, instead of putting 5,000 a year, it's 5,000 divided by 12, right? I would have put something in each month every time it compounds, right? And maybe, I mean, I would look at the stock market too. Right now, the way rates are, interest rates are, like on savings, there's not much return on your money these days, right? Like money is almost free right now, isn't it? You say that if you think of the interest rates across different countries on the planet, it kind of tells you about the value of their currency, doesn't it? I'm kind of glad you asked that, right? Because right now, our interest rates are close to zero, which means the value, like if you need to get money and borrow it, what does it really cost you? Not much. See what I mean? So if you're running a business and you need money, you're probably going to want to borrow, versus maybe issue stock, right? And make that choice a little easier, right? You only have to pay back, less than 1%. Why give up ownership, right? Now, if rates are 15%, you got to pay that back. Maybe you thought, okay, maybe I will, go public and give up some ownership, right? Okay. So, what was the check work doing? What's the check on this one? How much more interest? Yeah, okay. You got it. We did the same thing. Okay. Let's go to example 3. We're going to run through with the formula. Make sure you do the formula one more time, and then I'm going to show you the trick. Okay. Let's go to the next page here. Oh, I don't want to take that back. All right, example 3. I got my turn already. Lyndon Robbins, we got different people. Online savings account, 1% annual interest. It's like, why are you bothering, right? Why, you could do so much better with that money than get 1% on it. But anyway, here we go. Well, okay, at least they found something compounded how often? Read that problem. Oh, that's right, I'm reading. Monthly. Okay? So now they're doing periodic deposit, $1,200 every month. Right? How much would be in the account after 10 years? Okay? So let's set this up here, right? And you don't have to do it. I like to write out what all my variables are, and that just gets my mind thinking clearly about what goes where, right? So the rate is 1%, so 0.01. And how many years is it? Or how many compounding periods is 12, right? And then we got the payment each month was how much? $1,200. And it's 10 years. Okay? So let's plug that in here. So our balance is going to be 1,200, double parentheses, 1 plus 0.01 over 12 to the 12 times 10 minus 1 over 0.015 over 12. Let's see if we can do this once more. On our calculator. It's in the book, but I want to make sure you guys can get it. 151, 379, 85, right? Were you able to get that? Okay. All right. So now you demonstrate it. It's kind of a messy formula, right? You got to think about grouping and having enough self-respect not to use something like a fraction button, right? Well, so here we go. I'm going to show you a cheat that's even more egregious than a fraction button, right? And that's okay, see, because like once you learn something in math, and then you want to go on to investigate it even more deeply, you want the convenience of something that will handle the messy stuff, so you, right? And so these calculators have what's called a time value of money function in it, okay? So we're gonna do the same problem again. So it's the TVM, time value of money function, okay? So what you want to do this is open a new doc, right? And then calculator. Might even be able to do it from Scratchpad if I'm not mistaken. But either way, calculator could be the Scratchpad calculator if you like. Calculator, okay? And you're going to hit the menu button. All right? And then that menu drop down will be the word finance. Okay? What? So watch the updated operating system. That needs to be a little different than what I'm writing here. Go to Blue Notes. Okay? And then, under that, you want Finance Solver. Okay? So let's see if we can enter this into the Finance Solver and get the same answer. We're going to do the same problem. Okay? Let's see if we can find this. And there's a couple of, you got to pay attention to a couple of tricks that we do here, okay? So, I think I'm going to try it with this Scratchpad. All right. Here. Menu. Oh, there it is, right? This is finance number 8. Okay? And you want number 1, finance solver. And this will work for a lot of the stuff we do. Okay? Now you notice what it's a capital N here, right? That's our little n. That's a number, right? Compounding periods. But it's slightly different. It's the total number of compounding periods for the whole term of the investment. So this thing is compounded monthly, so it's 12, right? And for how many years? 10. So what you have to put in here is 12 times 10. Right, 12 times 10. With me? Okay. Now, notice the I, percent, interest rate. We don't have to convert, remove the decimal. You got me? But we do have to do a certain thing. What's the annual rate in this problem? 1. But we need the monthly version of that. So what do we do to that 1? Divided by 12, right? Click the R over N, right? So we don't change it to 0.01. You got me? You see how it says percent there? So we put it in this as a percent. So 1 annual, but it's compounded monthly, so we have to do divided by 12. Got me? And then arrow down. Right? Present value, right? That would be like your opening single deposit if there was one. Okay? Right, like if you open an account with $50,000 and didn't touch it again, that would be your PV. Now, here's the other thing. Listen, we have to think about positive and negative. Okay, everybody listen to me? If money's coming out of your pocket, would that be positive or negative cash flow? Okay, so negative. How much are they putting in each month? 1,200. So what should we put in under payment, right? So let's go down, and we need to do negative 1,200. Everybody got that? If money's going away from you, we need to call it negative. And at the end, when they reap the benefits, that value needs to be positive. It's going back to them, right? So future value. Okay, how do we get that to calculate? So you go down, get your cursor in future value, and just hit enter. Is that what we got when we did it by hand? Okay, you get it though, right? So N is the total, it's a capital N, right? Not the little n. So it's the total of all the compoundings that happen, right? So in this case, it was 12 times 10 years, 120 of them, right? And this is your rate as a percent divided by 12. If it was compounded quarterly, it'd be 1 divided by 4. Does that make sense? Yeah. There was no opening single deposit, okay? We just had that. You could probably guess how to do this for single deposit, you know, like our compound interest formula. Instead of making regular payments, they just put in $5,000 to watch it grow. You'd put negative 5,000 here in PV for present value. Okay? So neat little solver there, right? So do it by hand a few times, and now you can do it with this thing, but you can get the little tricks, right? Okay? All right, so now that we have that, we can save ourselves a little bit of time. Let me just write, I want to make sure this is in your notes, right? So for N, when you get in there, that way if you forget, I'll have this here, right? For the N, we had to do 12 times 10, right? And then it had I, interest percent. We had to do 1 divided by 12, okay? The PV, present value, we left that as 0 or blank, right? And then the PMT, payment, that was negative 1,200, right? One of these has got to be a negative value. And when you arrow down to FV, future value, what will you get at the end, right? You just type, press the enter key. Right? And when you do that, it'll show 151, 379, 85 cents. Okay? So if you kind of forget how to enter that stuff in your calculator, it's in your notes here, okay? We got that jotted down? Okay. We have one more example of this section here. They want us to graph this future value for Linda and Rob. So on that last example, this could get tricky. You think? Too much? Remember, it's a 200 level college class. You're getting it for free. All right. All right, let's go to example 4. See what this graph looks like. And the way they have the graph in the book, it's a little deceiving. So that future value formula, would you guys agree that that's exponential? No. Well, there's variable in the exponent, right? Time and array, right? All right. And you guys know the exponential functions are like this. Like exponential growth does this. Look at the graph they have. Does that look like, that looks linear, doesn't it? And they're using an exponential function. Now, they just put in, see how they simplified the formula down there at the bottom? Okay. So X is like whatever it is, you know, times the number of compounding periods. Okay. So they're letting So they're letting NT, the NT in the formula, the N times T part, they're just letting that equal an X. Right? So your X is just going to be it's like the capital N in the solver we did. Okay? So let's put this in, and I'll give you an interval here. So we're gonna do basically our balance equals 1200 times 1 plus 0.01 over 12 to the X. Okay, let me just emphasize. We're going to just use an X up here. Okay, minus 1 all over 0.01 over 12. All right, and we're going to put that in the graph, and I'll give you the interval that'll make this. So why do you think their graph looks straight when you know that it's exponential should have a curve to it? Yeah, how? What do you mean? It's exponential, but is it would you say it's a really fast growing exponential, super fast? Not really, right? So what could they have done just to make it look constantly? How could they have presented it? Yeah, right? The X and Y range and stuff. You could have, if they went out far enough and high enough, you start to see a curve in there, wouldn't you? So we'll do it so that you can kind of see that, right? So let's graph it for 0, X between 0 and 1,000. You know, change your window. And then Y from 0 to, let's go to 2 million. All right, so let's put that in there. And listen, the x-axis, listen guys, this is compounded monthly, right? This x is n times t, 12 times t. So x, in this case, when we graph it, will be the number of what, you guys? Years? Okay, stop what you're doing for a second. I need to answer this. When we graph it, the x-axis, will it be the number of years? So x will be the number of what? Months, right? You got me now? So like if you were asked to say, like, you know, how long until it gets to this point, you'll say 60, x is 60, but wait, that's 60 months. That's only 5 years. You got to convert, right? So this is important. X is number of months. Okay? So we got to be careful because it's divided by 12. So let's put that in there. You know, it's the window I had you use. It's quite a bit larger than what they did. Hopefully we'll start to see the curvature of it. And by the way, down when you're using this finance solver, don't worry about any of this stuff down at the bottom, okay?
What was the X max?
2 million.
What was the Y max?
1,000. appreciate that. I think you kind of see a curve in it now, a little bit. Yeah, you got a curve? Well, please use talk English. I ain't got no curve. What does yours look like? All right, let's see here. Tom Hunter. You didn't group bottom. Don't take that first. You didn't group the bottom denominator. You have parentheses on the top. Yeah, group it. Let's see. When I put it in, I put parentheses around this on the bottom. Okay. So did you guys get the pad? Now it's got a little curve to it, right? Okay. Because we opened it up quite a ways. We had to go out to 1,000 months, which is a lot of years more than you probably ever do it. But it's exponential, but it's not a very strong exponential, but it is exponential. 1%. Right? Not much for that small. Okay. So let's see here. In 5 years, here's the follow-up. Okay. In 5 years, what's the value? We could go to our graph. Here's where you got to be careful. I said X is in what? So in 5 years, we need X. We need to look at X equals what? Not 5 to get the value of what? 60, right? 60 months, right? So then we can go back to our graph and do that, trace or whatever. Let's see. Get the value. Now if we go to a graph and do menu, I think it's trace, right? 5. Graph trace 1. 5. I think I can just type in 60. Yeah. Does yours just split? So we did that. Yeah, I don't know why mine does that. It goes into scientific notation. So we're going to do 798, right? But you get the trick here, right? They want 5 years, and you do X is monthly, right? So you have to do like 5 times 12 to get correct X out of it, right? So in 5 years, X equals 60 months, which means that the balance was 73,798 and 86 cents. Okay, so that's the graph of that thing. All right, and I just didn't like how it didn't look exponential in their graph, so. All right. Do we have any questions on this? Well, let me talk, like, the next steps. Some of these formulas you're going to want definitely note cards. Starting to get messy now, aren't they? You can work with them, but they are starting to get messy.